In 1954, archaeologists found something disturbing in a pyramid shaft: the skeletal remains of a worker. His bones showed evidence of a catastrophic injury. A massive stone block had crushed him. But that's not what's disturbing. What's disturbing is that this pyramid was built 4,500 years ago. And in all that time, nobody has satisfactorily explained how. This is the Great Pyramid of Giza, and behind its perfectly aligned stones lies one of history's greatest mysteries. How did they build it? Not who built it. We know it was Egyptians, but how, using the tools and knowledge we think they had, remains impossible to explain. I'm going to walk you through what we know, and then I'm going to show you what we don't. The first time I studied measurements like this, I thought there was an error. Nobody can be this precise without modern tools, but the pyramid is real. So either our assumptions about ancient tools are wrong, or there's something we're missing. Around 2589 BCE, a pharaoh named Khufu came to power. He ruled Egypt during the Old Kingdom. His reign lasted approximately 24 years. In that time, he commissioned the construction of the largest structure ever built by humans, the Great Pyramid of Giza. Today, it remains the only surviving wonder of the ancient world. Let's be clear about what Khufu achieved. The Great Pyramid contains approximately 2.3 million limestone blocks. Each block weighs between 2 and 8 tons. The largest blocks weigh 80 tons. The pyramid rises 146 meters into the sky, nearly the height of a 40-story building. Every edge is aligned to within fractions of a degree to true north. Every angle is precisely calculated. The precision is extraordinary. The difference between the longest and shortest side is only 20 centimeters across a base of 230 meters. That's a margin of error of less than 0.1%. If you were to build a modern office building with this precision, it would be considered a miracle of modern engineering. Yet Khufu's builders achieved this 4,500 years ago. I often wonder if Khufu knew what he was starting, if he understood that his pyramid would still be standing 4,500 years later, that we'd still be asking how it was built. Some estimates suggest the project employed 100,000 workers over 20 years. The cost? Some scholars calculate it consumed 30% of Egypt's annual wealth. That's not a tomb. That's a national obsession. Let's get specific. The Great Pyramid isn't just large, it's precise. Base dimensions: north side, 230.25 meters. South side, 230.40 meters. East side, 230.39 meters. West side, 230.36 meters. Difference: 15 centimeters across a foundation of 230 meters. Remarkable. Height when built: 146.6 meters. Today, 138.8 meters, because the outer casing was removed in the medieval period. Angle of incline: 51 degrees, 50 minutes, 40 seconds. Perfect. Now, why am I giving you these numbers? Because precision at this scale is not accidental. It requires a detailed architectural plan. Not just a concept, an actual blueprint, mathematically calculated. Inside the pyramid, there's more complexity. The Great Pyramid has 3 main chambers. The King's Chamber, made of red granite, sealed with a 9-ton granite plug, accessible only through a narrow passage. The Queen's Chamber, smaller, also made of limestone. The Subterranean Chamber, cut into the bedrock below the pyramid. Connecting these chambers are passages. Some are narrow, some are steep. Some have air shafts that penetrate to the outside. Why? Researchers have proposed ventilation, but the angles suggest something more purposeful. Astronomical alignment, perhaps? Or something else? Within the king's chamber sits a red granite coffer, a single piece of stone hollowed out. How was it cut? With what tools? And when was it placed? It's too large to fit through the passages. It must have been placed during construction, which means the chamber was planned from the beginning. This wasn't an afterthought. Every detail was predetermined. The walls are covered with fine white Tura limestone, polished smooth. The joints are so tight that you cannot fit a human hair between the blocks. Many of these joints remain intact after 4,500 years. This is not the work of a primitive people. This is precision engineering. Full stop. The first time I saw precision measurements like this, I felt something shift. I realized I didn't understand what I was looking at. Egyptologists have proposed several construction methods. Let's examine each one. Theory 1. Ramps. The most popular theory suggests the builders used ramps, earthen or stone structures, to haul blocks up the side of the pyramid. How would this work? Workers would quarry blocks of limestone from nearby. Each block weighs 2 to 8 tons. Teams of workers, perhaps 20 to 30 per block, would drag them up a ramp using wooden sledges and ropes. This is theoretically possible. Experiments have shown that teams of workers can move stone blocks using this method, but there are problems. First, the ramps. Where are they? We found no archaeological evidence of the massive ramps required. Some scholars suggest they were dismantled after use, but dismantling a ramp 500 meters long would take months, and we'd expect to find traces. Second, the mechanics. As the pyramid grew taller, the ramps would need to be longer to maintain a manageable slope. The volume of earth and stone required for these ramps might equal the volume of the pyramid itself. Third, the timeline. If 100,000 workers placed blocks continuously for 20 years, that's one block placed approximately every 5 seconds, 24 hours a day, with perfect coordination, perfect logistics, no breaks. Is this physically possible? Perhaps, but it's not efficient. Theory 2. Water-based transport. Some researchers propose the builders used water channels and wooden barges to transport blocks. The Nile runs near Giza. Blocks could theoretically be moved by water during flood season. Evidence supports this. We've found remnants of ancient causeways that likely served this purpose. The Tura limestone used for the outer casing came from quarries across the Nile, clearly transported by water. This theory is more plausible than pure ramp transport, but it still doesn't explain final placement. How do you take a block off a barge and position it precisely on a pyramid? Theory 3. Spiral or zigzag internal ramps. In the 1990s, engineer Jean-Pierre Houdin proposed a revolutionary idea: internal ramps inside the pyramid itself. His model suggests the builders constructed ramps within the structure as they built upward. These ramps would be gradually sealed off as the pyramid was completed, becoming the internal chambers we see today. This is brilliant. It solves several problems at once. No external ramps needed, efficient use of space, explains the internal structure, accounts for precision. But, and this is important, we have no direct archaeological evidence. The internal passages don't quite match his model perfectly. None of these theories is perfect, each has problems, which suggests one of two possibilities. The builders used a combination of methods, adapting as they went. Or there's a method we haven't considered, something we're missing. After 50 years of serious research, we still can't agree on how it was built. That's not because archaeologists are bad at their jobs, it's because the evidence is ambiguous. That ambiguity is the mystery. Here's a practical problem. Construction takes 20 years. But the pyramid was Khufu's tomb. He ruled for 24 years. That means the tomb wasn't finished until near the end of his reign. What if he died before it was finished? What if his successor had to complete it? The historical record is unclear, but this raises a question. Was the construction process truly continuous? Or were there pauses, modifications, revisions? The precision suggests continuous, coordinated effort, but the timeline suggests it might have been interrupted. Let me talk about the tools. The limestone blocks were quarried with copper tools, copper. Modern experiments show that copper tools can cut limestone, but slowly and with significant wear on the tool. A single copper chisel can process maybe 10 cubic meters of limestone before becoming useless. The Great Pyramid contains 2.3 million blocks. Even if 30% were cut on site and the rest were quarried elsewhere, that's still massive stone removal. The number of copper chisels required? Hundreds of thousands, and we've found few. Also, some blocks show saw marks. Horizontal saw marks. Copper saws cutting through limestone? Possible, but slow. The precision of these cuts suggests something more capable than copper saws. Moving 2.3 million blocks in 20 years requires not just labor, but logistical organization. You need supply chains for food, water, tools. Coordination of workers across multiple sites. Precision scheduling, quality control, medical facilities. Remember the crushed worker we mentioned? We have no administrative records of this scale from this period. The papyri we found don't document anything approaching this complexity. That doesn't mean it didn't happen, it means the records are lost. But it does mean the organizational capacity required was extraordinary. Here's what I think. I don't think it was aliens. I don't think it was supernatural. I think the Egyptians were brilliant, and they achieved something remarkable. But I also think we're underestimating what remarkable means. In every human civilization, certain knowledge concentrates among specialists. In medieval Europe, architectural knowledge was held by guild masons. In ancient China, bronze working secrets were guarded by government specialists. What if ancient Egypt had similar specialists? What if there existed a class of engineers whose knowledge was passed down through apprenticeship, protected from general knowledge? We assume the Egyptians left records of everything important. But what if the most important knowledge was intentionally not recorded? What if it existed only in practice, in training, in hands-on instruction? That would explain why we see the results, the pyramid, but no clear documentation of the method. I think about the worker whose bones were crushed. We don't know his name. We don't know if he volunteered or was enslaved. We only know he was part of something massive, something that required sacrifice. And 4,500 years later, his presence in those bones reminds us, this wasn't theoretical engineering. This was real people, real effort, real consequences. The pyramid is a monument to human achievement, but it's also a monument to human cost. And both parts of that truth matter. The engineering mystery of the Great Pyramid isn't really about how did they build it. It's about what did they know that we've forgotten. Every time I stand in front of these walls, and I have twice, I feel smaller than before. Not because the pyramid is large, but because I'm standing in front of a problem I don't fully understand. And that feeling never gets old. The Great Pyramid of Giza remains one of humanity's greatest achievements, and it remains fundamentally a mystery. Not because we lack hypotheses, we have several, Not because we lack evidence, we have plenty. The pyramid itself is the evidence. But because precision at this scale, achieved 4,500 years ago, with the tools we believe existed, strains the limits of our understanding. Does that mean the standard explanation is wrong? Not necessarily. But it means we should remain humble. Humble about what we think we know. Humble about the capabilities of ancient people. Humble about the limits of our understanding. Because maybe, just maybe, the real mystery isn't how the pyramid was built. It's that we've forgotten how to build what our ancestors could build. And that should make us wonder, what else have we forgotten? If you're fascinated by this mystery, by the questions archaeology can't fully answer, subscribe to Forbidden Echoes for more deep dives into history's greatest enigmas. I read every comment. Tell me which part of the pyramid mystery fascinates you most. See you next time.